Dart skill presents real-world problems. Several situations in our real life involve two variables that are related by the equation of a straight line, that is y is equal to mx plus c. When you draw the graph of such a situation on a graph paper, perhaps to make future predictions, the process is called mathematical modeling. Let's look at an example. Let's say the monthly salary of a salesperson is divided into two parts. One part is fixed, and that's 3,000 Rand per month. The other part is variable, and it actually depends on the number of sales he makes. And let's say that's 200 Rand per sale or for every sale he makes. So that's a kind of motivation or incentive that the company wants to give to the salesperson and tell him that, okay, you want to earn more, you sell more for us, for every sale you make, we are going to pay you 200 Rand over and above your fixed monthly salary of 3,000 Rand. Let's say his monthly income is I, and the number of sales that he makes in a month, which is not fixed, it keeps changing, is S. And the question to be answered is, how is I, his monthly income, related to S, the number of sales he makes in a particular month? Let's first try and relate the number of sales made and the variable income. So if he's selling, if the number of sales is 1, the variable income is going to be 200 Rand. It's given. Now if he's selling 2, so if the number of sales is 2, that's going to be 2 times 200, because for every sale he's going to make 200 Rand. So this is going to be 200 times 2. And if he's selling 3, this is going to be 200 times 3 and so on, right? This is times 1. So if he's selling, if the number of sales is, let's say, S, which is a variable, so the variable portion of his income is going to be 200 Rand times S, or written as 200 S in algebra. But this is over and above the fixed salary. Even if he cannot make one single sale in a particular month, he's still going to receive 3,000 Rand. Let's say because of the time and effort he's going to put in. So his monthly income is actually equal to 200 S over and above the fixed income, which is 3,000 in any case. And if you just rearrange these terms, we have I is equal to 200 S plus 3,000. And now if you compare this equation with y is equal to mx plus c, it makes a whole bunch of sense. Y is the income, the monthly income, it's a variable. S is the number of sales made, that compares with x, so that also is a variable. And c is the y-intercept, meaning that when x is 0 or s is 0, when he has made no sale at all, even then the y value or the income is going to be 3,000 Rand. Now on the coordinate axis, this is x, this is y. Let me just write that down, x and y. X, or the input, is actually the number of sales he's making in a month. So the x-axis represents the sales. And the y-axis is his monthly income, the total income. And as we see from this equation, the y-intercept is 3,000, which means it starts at 3,000. From here to here is 3,000. And obviously the equation is that of a straight line. Y is equal to mx plus c. with a positive slope of 200. Which means it goes up like this. And there's no point in this particular scenario to extend this line on this side of the x-axis because you cannot have a negative number of sales. So you should take into account the situation in real life that's being plotted to find out if you should really care about the negative direction of the x-axis. And if you want to make a prediction about the monthly income that he would make for a certain number of sales, let's say 100, of course you could plug in 100 for S in this equation and find I. But if you want to do it graphically, all you would do is you will find out where actually is the straight line X is equal to the given value, let's say 100 like I said. So where is the straight line X is equal to 100, which is this straight line parallel to the y-axis, going to meet the given straight line represented by this equation, and you just got to find the corresponding value of y, which means what is the income when the sales is 100? This is what you call linear modeling.